Hey guys, I bought an electric bike for some reason. I, I have this, which is like an enclosed recumbent, and it's definitely faster than the electric bike. So it's also like the electric bike isn't, you still have to pedal a little bit at least. So that's pretty much the same as this. So I'm not 100% sure why I bought it, but it was cheap. So there's definitely an electric motor here, but no battery. Well, there is a battery charger in the wall. I'll show you why there's no battery on here, because we'll be looking at the battery and the electronics. Kind of interesting to note is the only real interface it has is, I guess, this thing, which is like a gas lever ish, and it's got like a power indicator and high and low something. I'll show you what everything does. By the way, I bought the bike for 90 euros, including two batteries that are still good, but again, you know, good is a fluid concept. So here is the casing that the battery goes in. It's actually empty right now because I took the battery out. Quite a large thing, pretty thick as well. Let's see if I can show you. It's like this. Big aluminum extrusion. Have to say quite cheap construction, just using an aluminum extrusion with end caps screwed on. Very typical of low-cost construction. And inside is this monstrosity. This is just ridiculous. It's a nickel metal hydride battery. I was kind of surprised to buy a bike. This bike is from, well, the model is from 2011, and this particular bike was from 2012, so it's only 4 years old. I was under the impression that nickel metal hydride was kind of dead since halfway through the century, because it's actually more expensive and has much lower performance and lower capacity and higher weight. It's just like in every single respect, nickel metal hydride has been worse than lithium ion for a decade now, for a very long time. Lithium ion has even surpassed lead acid in every possible way. It's cheaper nowadays. The bike is a very low cost bike. Obviously, I bought it for 100 euros or 90 euros. That's nothing, but even when it was new, it was like $5.99 or $6.99 depending on the battery. For that kind of money, you would expect a manufacturer to use the cheapest possible materials, which is lithium ion stuff. Yes, it needs battery management. Yes, it needs some other stuff. I can't imagine this being cheaper. Anyway, so this is only 24 volts, 9 amp hours, which is about 200 watt hours. It weighs close to 5 kilograms. I mean, come on. 5 kilograms of lithium ion buys you like 750 watt hours. I actually got two, count them, two batteries with the bike. Because the first one, apparently they thought it was busted and they had a new one rebuilt. Jeez. For 400 euros. So some company made very good money off of these people. They basically spent 1,000 euros on a very subpar bike and then sold it to me for 90. Now, the first thing I saw when I saw the advert is that the bike had a crystallite DC 24 volt motor. These are very typical. I'll include a picture of the motor. These are very typical motors. They don't really do brushed anymore. Brushed motors are... The pros of a brushed motor are there is no electronics inside. It's just a mechanical device. So it's very simple to drive a DC brushed motor. You just put a voltage on it and it turns, and you put a higher voltage on it and it turns faster, or you put PWM on it to modulate the speed, whatever. It's very simple. Brushless motors, the typical ones, like the bipolar ones that are used in most bikes, they need multiple signals. Basically, they need a controlled PWM waveform, and you don't actually know exactly which way it rotates just on its own, so it needs some smarts in there. So it won't come as a surprise that this is literally all the electronics in the bike. Now, unfortunately, I don't really have proper bicycle electronics to show you to show like a comparison. But what I do have is this eBay controller for brushless DC motors, and as you can see, it is quite substantially larger. I wouldn't have a look at it in this video, but I can assure you there's a lot more complexity going on in BLDC motors. I mean, if they're probably cutting a lot of corners in this thing as well. It's still quite a bit bigger, so. Nah, this thing is just a box of fun, honestly. First of all, this is not how it came. Obviously, I already screwed off the little back plate here. It was mounted to here, but there was also like a little plate on here still. Kind of interesting was that when I took this out, already had a look, there was tape, duct tape, like the gray stuff, over here, all the way over here to protect these electronics. I mean, that's called structural duct tape. That's something they put in the factory, and you're not really supposed to do that. You know, it's a very bad way to insulate your electronics. Also, I mean, why would they put these MOSFETs on the outside? It doesn't really make much sense, to me at least. It just starts out so bad. The protection in here is a big car-type fuse. The problem with these fuses is these are made to be very resistant to short surges, and most likely your bicycle will catch fire on medium and short surges, so you don't want these very slow blow fuses in your bike. You want the quick blow, or you just want an electronic current protection circuit. Also fun is that this is actually an ignition switch. The battery goes onto here, and the battery actually is just directly connected to this, which is the charge port. So there's battery voltage here somewhere on an uncapped. These contacts are in direct contact with outside air and with moisture and rain and everything. You can actually see it. It's a bit hard to see on the screen, but there is a lot of corrosion in here. This is a battery through connect. You can actually connect two batteries together to get a longer range, which is still like 20 kilometers. I've had a couple of rides on the bike. It's very anemic. The battery is, it goes really fast the first 2 kilometers, and after that it just drops like a brick. That's nickel metal hydride for you. As I said, driving a DC brushed motor is just so simple. It's just putting PWM on the motor itself. So basically what you see here, you see some caps for decoupling the power, because I mean it's still 250-ish watts going through here. Little Atmel microcontroller and an LM339 gate driver, and that's it. Well, yeah, there's a current shunt here, or what seems like a current shunt. 0.22 ohms. That's actually quite a lot. That's gonna get hot at full power at least. And yeah, just crappy soldering work. And I mean, geez, people, this I just don't get, right? Sorry, I actually misspoke. These are obviously diodes on the outside. Still dirty though. These do like the switching between battery packs. So if one battery pack's voltage is higher than the other, then that will actually be driving the motor. That's wasteful as well. These are just these are Y2010s. None. That's good of diodes for this application, honestly. So that little gas gauge on the front of the bike, well, I guess there are two inputs. There's a sensor, just a Hall effect sensor that's on the bottom bracket, so where your pedals are. When that senses a little magnet that goes in front of it, it just engages the motor at the gas gauge level. So the gas gauge is also a little Hall effect sensor that measures the position of the lever and then feeds that back into here. So that obviously goes into well, either the ADC of the little Apple microcontroller, or it maybe goes directly into the LM339 to do like PWM based on voltage. So it's voltage controlled PWM. That's how it works, and I am surprised that this is legal for a couple of reasons. So first of all, these electronics, these are uncoated in a very poorly weather protected box. The electronics are, there's no real proper current limiting, there's no real, like, obviously this is going to get pretty hot. The traces aren't thick enough to conduct with like a peak power of 15 amps. This is underpowered electronics. This is going to break pretty soon, and I would expect these bikes to actually fail reasonably quickly. Maybe what they're doing is they are relying on the fact that these nickel metal hydride batteries just go flat after 5 kilometers. So this will never heat up for more than 5 kilometers. After that, the actual power that the packs can deliver is sub 200 watts, and it's all limiting itself essentially. So what it does, it detects a magnet that goes by the little sensor once per pedal rotation, which means that it has quite a long timeout. It has like a timeout of 1.5 seconds. So if you start pedaling and then just stop, the bike will still go at full power forward for like 1.5 seconds. That can be like 10 meters, 20 meters if you're going fast, if you're going 25 kilometers an hour. Also, kind of surprised, there is no speed control at all. There's no feedback from the motor. The motor is just, it's a brushed DC. This is a 2-pin. I don't believe they do back EMF measurement. Maybe they do, but I don't see the required front end for that. And these microcontrollers cannot do that on their own. The ADC is not fast enough for that. So this essentially, like if you're in an emergency situation, you stop pedaling, you engage your brakes. Not only do you have to brake with a much heavier bike, like the bike in total, including the batteries, the battery packs all together, all the electrics is like 12 kilograms extra. So you've got a good 35 kilograms of bike instead of a normal bike, which is like sub 20. Plus a motor that is pushing you forward with about 250 watts, best case. What if your brakes are already a bit meh? This is kind of dangerous, right? Drivers, especially car drivers, they kind of look at body language. People on bikes are not generally super good at signaling. They don't really signal that they're going left or right or stopping or whatever. They hold their pedal still if they're about to brake or about to do something, and then at the last moment maybe they signal. So drivers kind of depend on this body language of cyclists. And if you're holding your pedal still, but the bike is actually still moving, and it doesn't really look like a motorized device, I think drivers can misjudge the actions of cyclists more easily. So I would classify this as a little bit dangerous, honestly. And yeah, I don't know what to think of this. The upside, of course, for me is that this is ultimately hackable. If I just replace the MOSFETs with better versions, if I thicken the traces a bit, put in better caps, make like the gas gauge better, or make it like a digital interface, fix these stupid diodes, like just remove the diodes and just have one battery pack. This can be a really cool bike to tinker with, and that's why I bought it, I guess. I don't really know why I bought it, but on like second look, it looks very hackable, very cool to do stuff with. So yeah, that's my electric bike.